Draft physics video. I think just some comments that provoke some thought, so I thought I would do a couple of them. Not too many great comments, unfortunately, but that's what there is. It would be nice to be able to organize some sort of conversation about physics that people could do in videos and have response videos and interact on subjects, just basic ones like what problems does the notion of ether create, or something like that, or how can it function, and I don't know, what's a photon, different arguments about why we should believe it's this or that, and evidence and that kind of thing. But no, can't do that on the internet apparently. Anyway, can't do it from here anyway. Has to come from the top down, I think, and they don't seem too interested. So yeah, I didn't think Professor Lewin would take my video too seriously, and apparently he didn't. But I thought it was reasonable input, just in the sense of understanding that the problem is better understood in a real circumstance that's frictionless, rather than creating an Earth circumstance where you have to create a frictionless environment and all of that. But whatever. Moving on. So Ingrid asks, why, Gary, are galaxies so flat? I don't know whether they're so flat, but yes, they are flat. And something that seems kind of obvious is, you could say, it's because their core is binary. So the core is made of mass orbiting each other. Not a centralized thing, but and obviously that would create a plane that everything would happen on. So that might be an easy answer, is that would be the seed of flatness, would be a binary system. It would just obligate there to be flatness, because there's going to be a lot more gravity on that plane than there would be in any other direction off that plane. So it would be very conducive to flatness. Now our solar system is semi-flat, but that flatness comes out of the fact that the mass tends to go where the mass is. And it's the same thing sort of with the rotation of the objects in a gravitational well. If there's objects moving in two directions, they'll eventually annihilate and end up moving in the direction that has more energy. So whatever direction has more mass going in that direction will consume the mass, the momentum of the other direction, and have a residual rotation. So there's certain kind of rules like that. So yeah, the whole argument about galaxies is, in my opinion, one of those things where there really isn't much conversation about different ways of looking at galaxies and understanding the difference and what happens in solar systems, and why galaxies don't do what solar systems do. Why doesn't the matter coalesce? And one of the arguments is because it can't, because suns don't combine well at all. Not well, and they can't get any bigger. But we can't know for sure that there aren't dark objects, and we won't say dark matter, but dark mass in the universe, masses that aren't nuclear furnaces. I would kind of suspect that nothing can get very massive. You can't have a high density of matter without always creating the radioactive problem, without always creating. It's like uranium is quite harmless when little bits of it are all over the place. It's when you put it next to each other, smash it together, that all of a sudden it becomes very unstable and very radioactive, in a sense. It bothers itself, and I think that happens with all atoms, that if they're in a dense enough mass, they degrade. They heat up. They nuclear furnace in one way or another, whether it's fission or fusion. The matter degrades, and that energy facilitates more degrading. So that's why you don't have any huge suns. There's a certain limit to how big the little round things get in the universe, and that's how big they get, and they don't get any bigger. And so there's these rules, limitations. But there's no obvious transition from something small like the solar system into something big like a galaxy, but solar systems don't have the mass equality. The idea that there's a same amount of mass on one side as there is on the other side. Solar systems behave entirely differently. Everything's rotating around a center mass, and they're not rotating around each other. Where I'd say galaxies have every appearance that they were born of some other manifestation. Now, I would argue we don't even. I guess I would argue that anyway. I mean, I'm not a fully versed on every detail we know about galaxies, or every experiment, or every observation. But I don't know whether there is any hard evidence or complete evidence, satisfactory evidence, indicating that we know that galaxies are formed by matter condensing, or whether galaxies are formed by some other mechanism, the early universe, and these are really masses falling apart. That galaxies are the degrading of some more consolidated mass, and that's why it's so evenly distributed, is because it's spilling out, not being pulled in. This goes to the whole argument about observed speeds and why the thing isn't rotating by the same laws of a solar system, why the suns in a galaxy are moving too fast in the outside rings or the outside areas. And I would argue that it could sort of be explained if you recognize that the gravity isn't this one piece of mass against the rest of the entire mass of the galaxy, that it's all a bunch of gravity that's interconnected and woven, and frankly maybe way beyond our capacity to calculate accurately exactly what the gravitational influence is, because you have to calculate it through a billion individual interactions rather than just 2 points, the center, the sun, and the earth. That calculation would be incredibly complex if there was an asteroid belt much closer to the earth. Then that calculation would get very complicated if there was any clumps of heavier mass in that belt. It would it would have a long-term effect on changing the precession or the movement of the earth, and exactly figuring out how much tug or pull would get quite complicated. So I don't think they can know that galaxies are doing something wrong or inconsistent with Newtonian gravity, because I don't think they're necessarily able to calculate even Newtonian gravity without completely cheating in terms of identifying the point sources, because they're not points anymore. There are lots of points, billions of points, billions of interactions, discretely individual interactions. So, yes, I'd say sort of the answer, sort of. Obviously, if something was getting more massive and spinning, it would get fatter in the middle, as I pointed out before, and it would tend to spread out in that plane. Where, yes, it does seem a little bit unlikely that a big cloud of gas would be able to compress into suns and then move into the galaxy center. That doesn't seem very likely, in my opinion. It seems a lot more likely, and also when you look at what, often the residue around galaxies usually isn't just pure hydrogen. It's not the simplest elements in the universe. There's compounds in there and other elements floating around, and that's how it gets to all the other suns, is because it's being spread throughout the universe. And it's how did that stuff get there? except it had to escape the gravity of the galaxy in some sense. So, but anyway, who knows for sure. It's an interesting subject, very undercooked by physics in my opinion, and not a very open conversation about what's really going on. So anyway, I think I took care of this little bit nasty comment by Hans, but whatever, go ahead, complain. And I don't know what this is. It's not a ferrocell. I don't know what that. I don't know what you mean by it's not. It's what they call it, but whatever. And yes, it's the Thunderbolt project. They have released a conference last week about Sapphire results. I watched a half an hour of it, and they still hadn't got to anything meaningful. Just talking about their project, and well, we did this, and we did that, and we're trying to get a plasma, and so their idea is they're trying to make the sun, which is silly. They're not even really coming close to making any kind of sun. They're just making a light bulb of sorts. Fluorescent bulb, a big fluorescent bulb. So anyway, if it takes you a half an hour to get to your big announcement, then you kind of know that your announcement ain't much. And so I don't think they've proven that light moves slower. It says here they're claiming they have observed light to be slowed down, color shift. Well, color shift isn't slowing light down, so those two things aren't the same. And I would just argue that it just seems like they've spent some money on this thing. They duped some rich people into financing a project, and they have to justify it. So they sound just like the whole LIGO thing. They even start off with, listen to it. Listen to our sun simulation. So they even did this silly, let's turn it into an audible whale sound or something. Listen to the whale sound. Propagandist much, blah, 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 blah. So go ahead, believe what you wish to believe, blah, blah, blah. If you think electricity is the whatever and all of the universe, I mean, I can't say it any simpler than this. I think the facts indicate that electricity is just a byproduct phenomenon. Electricity is just moving electrons. That's how it's defined. And what's moving the electrons is a force, and that force is actually magnetism. And so they just have it wrong. It's not the electric universe, it's the magnetic universe. And the magnetic monopoles are... Go away. Stop. Shoo. The magnetic monopoles are the proton and the electron. And the force, okay, is the magnetic force, which is the electron force and the proton force, and blah, blah, blah. I've explained all that. Anyway. Alright. So, Polylogic points out, I think, something I pointed out in the video. To determine the component of force that rotates the object, subtract the force on the center of mass multiplied by the distance of the offset. Yes, but that's exactly what I was saying. What you're doing is just taking a proportion. So if this is a circle, and I cut the circle here, some midway point from the center to the top, the mass above that line is going to be less than the mass below that line, and that ratio will tell you how much is going to be rotation and how much is going to be skid, if you want to call it skid. I said that in the video. But anyway, never mind. Alright, I don't know, this Mickey Farley guy is a little bit... Anyway, not sure you're aware, but it looks like Ken... Okay, I blocked your thing, who cares? Physics, perceptions of Newton's... whatever, ouch, don't be hating. I mean, just useless, nuts, stupid comment, and get rid of that. Britney Spears chimed in. If you want to debunk his demonstration, then do it yourself. So this was on a stupid one that was so obvious. This is the one where he took the rigid, round plastic bottle and pushed it against a wall. Now, I don't have to do the experiment because I'm an informed, intelligent person, and I know that rigid plastic will not compress and go flat and just say, oh, okay, I'm comfortable being flat. No, it will dimple in the reverse direction. So if it's dimpled, if it's curved this way, and you force it flat, it will resist and it will dimple in the opposite direction. It's just a physical fact. I don't need to do the experiment, because I've done it essentially as a kid, as a human being on Earth. I know this is what rigid plastic does. So, fuck you, idiot. Let's see. They found a galaxy that scans dark matter. So whatever that means. SANS. S-C-S-A-N-S. SANS dark matter. They haven't found shit. Okay, so you can keep pretending they've done something, or they found something, or they have all this. They haven't done shit. Okay, it's all just talk and rubbish. Most articles are just rubbish, nonsense, speculation. The evidence part is little tiny shred of that, and the rest of it's just all their big bold talk. So anyway, the comment that I wanted to get to was this universal expanse, because it's just the idea of getting to a conversation about a rudimentary functions and why certain theories, I think, make a lot more sense than other theories. So part of this has to do with, you know, the ether theory as a foundation, and you know, I tend to want to be able to indicate some reason for people to understand that it's just an added complication, that you don't need to create a medium. It's just an unnecessary step, because in a sense anything would be perturbating or moving through your medium is behaving exactly as if it was a particle. See, their medium isn't like normal water, where, you know, the water pressure is pushed and the pressure moves out and spreads, and the medium actually absorbs the force as the pressure spreads. The strength weakens because it's spread out over a large area, and it's, you know, consumed by heat and different things that are created because of the elastic event of increasing and decreasing the pressure. So let's just say it's frictionless and there's no heat problem. There's still the spreading problem, and that's what waves do, and that's just fundamental to the word wave. But their waves are these special kind of waves that only go in one tiny, discrete, puny direction until they want them to spread, and then all of a sudden they let them spread for some reason. So somehow this medium has this ability to perturbate something in a perfectly straight line, just like it was a torpedo or a bullet cutting through jello, and then other times they make it into, you know, a bunch of dominoes that can go in all directions, and that in itself seems, you know, mentally confusing, unnecessary. So it's back sort of to the push-pull argument. Why try to defend pull when it seems obvious that the first cause is push? Alright, it's so much simpler. It's just that it's just so many degrees of it takes so much less infrastructure to do push than it takes to do pull. So why create the unnecessary infrastructure when the end result is going to be exactly the same? See, I could turn my particle theory, I could turn photons into perturbations. I could turn everything I'm saying, I could convert it into an ether theory if that would make you happy. I mean, I can make it ether theory. But in my opinion, it doesn't make any sense for me to come up with some bizarre way that the bullet is now going because the jello is propelling it. You know, it's not going through the jello. The jello really, you know, creates the bullet hits, you know, something pokes the jello. The poker stays where it was, pretty much, and somehow the jello carries the image of the thing through the medium. I mean, I can come up with some bizarre way that would be possible. I'm not exactly sure of those transition points, though, where that still would make any sense, like how it's a real thing inside the atom and all of a sudden the energy somehow converts from a physical thing, you know, something sort of real, into something perpetuity. You know, that part gets a little gnarly. But I could do it. But why would I do it? Why would I create a whole big artificial infrastructure when I already have the simplest thing possible, which is a little bit travels and goes to a destination and hits it? And why make it any more complicated? Alright, I had the idea that maybe the ether exists and photons moving through this ether creates light. Well, the photons don't create light, they are light. Okay, so they don't. So this is where you get into these field arguments, that there's this electric field and this magnetic field, some kind of ether, some kind of jello. So there's blue jello going this way and there's green jello going this way, and somehow the jello pressurizes and depressurizes in both of those mediums at the same time, so it goes whatever, green plus blue equals brown or whatever. I gotta add red or something, but anyway. So but again, how, you know, what's the mechanism? How does it know to make it go forward? How does it know? It just, you know, it's like, okay, you have these little, somehow these like kind of like dominoes, like Lego dominoes or something. They're connected to each other, but they're not, and they hit each other, and then they reset automatically. So you can have some kind of chain reaction go through the medium, and it's going through two different mediums, but it's not going, it's not spreading sideways. I mean, photons don't leave any residue behind. There's no real evidence that you can partially interact with a photon. So again, this is something physics is sort of clinging to, that somehow photons can go by something and say, I affected you. I didn't hit you. I didn't give you my energy, but somehow you know I'm here. Like somehow they transmit messages that they're around. And there's no real evidence that you can do that. I mean, the whole Einstein argument is that no, it's a discrete bit, a complete bit, and that's it. Either it's all or it's nothing. The photon hits or it misses. There's no, hey, I almost hit you. You know, that doesn't happen. There's no evidence that happens. All right, anyway. But then there is different frequencies of coherent light, and maybe that the frequency of pulses or photons creates different light colors, and that the number of photons per pulse is the strength or amplitude of the light. Now the strength is the number, clearly, and they're individually have their frequency. So you can't, you know, I just don't know what why would you, okay, so I'll draw, hopefully, in some form. I mean, the simplest argument I can make is that, you know, they're arguing, I'm arguing, look, this is photons, okay? This is red photon, and this would be blue photon. Okay, that's it. Now, the blue can look like it has more energy because in the same amount of time, okay, the red only has 4 and the blue has 5 corpuscles, bits of energy. So, and because they're coming at a quicker time, that in the circumstance where, you know, an electron is attached to something, you know, force-wise, it's magnetically attached to a proton, that if you hit it slowly, like one hits and the electron moves a little bit, the electron moves back. And if it moves back enough before the second hit comes, then all you do is keep bouncing it up and out and back and forth, but it never gets free. But if you hit it twice quickly, I mean, so the electron moves and then the electron doesn't get back, and then you hit it again, well, then you can knock it free of this bond. I mean, that's a very simple argument. It's a tipping point argument I've used, but there's probably another way to say that, you know, in terms of time being essential to what the product of the interaction will be. The timing of the interaction is essential to the how the end result. So we don't have any simple word for that like thermodynamics or something, but there probably should be a word for the fact that many things are vulnerable to that circumstance, that it's all about the timing. Now we have words like resonance and some words indicating that frequencies change and there's overlapping frequencies that make the intensity stronger and some notion of it, but there's no word that I know of that really gets to the core point that that's how photons are behaving, that they're in a condition, especially in atoms, where they're pretty stuck. They're not free electrons. They're, and even free electrons are often not free. They're loosely tied to something. Electrons in the universe, if I placed one in the universe, it's not going to stay there because there's no reason to think that everything around it is perfectly symmetrical. It's going to move. There's going to be an imbalance of force on one side or the other, and it is going to start moving. And it's going to keep moving until it gets to the place that's creating the imbalance, and it's going to find its balance position in a sea of imbalance. It's going to get, it's going to, so that's another thing about, the physics, is that you have circumstances where there can be lots of charge in an area and you're distant from it, and so it has a collective meaning of, it could be a +3, and you're a -1 or whatever, and so you have an attraction and you start moving in that direction. But once you get close to the object, it starts to change, because the +3 was really made out of a bunch of +5s over here and -2s here on the edge. And so what's going to happen is it's going to get attracted to the net total. But once it gets close, these interactions are going to be the strong ones. They're going to have their influence, because of the change in distance, the fact that they're much closer to these than they are to these, is going to mean that they're going to get stuck here and they're going to stop. Even though this is still a net 5, they're not going to see the net 5 anymore. They're going to see the strength of the -1. The -1 is going to control them, not the +5. Alright, so continue reading. So yeah, this whole idea of pulses and frequency. So I guess what I'm saying is, all right. So let me try to do justice to ether, or try. You can't even draw it really. You can't. In my opinion, you can't make any much sense of it without drawing it as discrete particles. How do you draw your perturbation as anything other than recognizing that there's something moves, and it's going to move just like it was moving through something. So we have this idea of some kind of thing at a frequency, and alright, so the frequency is moving in this straight line. Alright, it doesn't spread this way, doesn't spread this way. There's absolutely no evidence it does any of that. The evidence is it goes in a straight line, and the only way you see the photon is that you have an electron in your eye and the photon hits it, and that's the end of the photon. That's the end of that individual photon, in a sense. And now it's going to be converted either into a reflected photon of some other kind at some other direction, or it's going to be absorbed essentially, and that force is going to travel as an invisible photon inside of a mechanism, blah blah blah, and that's going to be electricity. It's going to push one electron, it's going to push another electron, it's going to push some other electron, it's going to finally push an electron inside of a neuron, and it's going to create a signal that the brain can keep moving around. And it moves it around because the force, the moving force, created a cascade because of how it had energized the system. So it's like a photomultiplier is taking electricity, so it takes a whole bunch of photons essentially, And it uses this reflection idea. I'm going to draw this right. Where it pumps a bunch of photons into these plates, and then it has a photon hit, an electron. But the electron is highly energized by a bunch of photons between the electrons. And so what happens is the electron flies off and hits the other plate, and then that creates even more disruption and more scatter, and so even more stuff flies off, and each time you're just multiplying how many electrons now you're flying across these electric gaps, because you added one tiny bit of extra current that created a liberty, enough energy for the electrons to start going across the gap, and so they just keep jumping across the gap, and you're multiplying it, you're chain reactioning it. So each time you free one electron, that frees 10 more, and you just end up with 1,000,000 times the amount of photons, essentially. So you're multiplying the photons by multiplying the amount of photons that are pushing an electron across the field. So what goes across the field isn't so much the electron that goes to the other side, it's all of the energy that pushed that electron is going into the other plate. So you're multiplying the force. You either get it or you don't. Some of this stuff is dependent on you having knowledge of some of this stuff, and I can't provide all of that. Can't provide all the background knowledge. All right. So the light colors are just a consequence of the frequency. You can't see the color unless the photon actually hits your light. So when you see a laser beam, you're not seeing the photons going back and forth. You're seeing a photon that hit a piece of dust or something else, a water molecule, and bounced into your eye. You're seeing an individual photon that came off of that changed its path and changed its route. But you're not seeing the beam. You're not seeing photons. You're seeing an individual photon that got kicked out of the school and flew into your eye. Alright. Let's see, strength and amplitude of the light. So again, this idea that light has an amplitude or a strength, no. It's just not there in the physics. So I've made this argument so many times. It's just the frequency has energy in and of itself. So as soon as you have something moving at a frequency, it can have consequential effects that are different. So, but that's all there is. You can't make the photon itself stronger. So a radio wave photon and a X-ray photon are exactly the same ton. There's no difference between them. They have exactly the same amount of energy. They're moving exactly the same speed. The only thing that changes is the fact of the frequency. The X-rays are coming quickly, and the radio waves are coming very slowly. Great deal of distance difference. And we see that as a change in energy. But the change in energy is this part. Twice as many in the same amount of time. And with X-rays, it's not even twice as many. It's 1 billion times more. So for 1 second of X-rays, you have 1 billion times more in one ray, one tiny trace. You'll have 1 billion times more energy. Now, obviously, a radio wave is spreading out, zillions of rays. So it has a lot more individual rays, but it has each ray has much fewer photons in it. So each burst from a radio tower is a huge burst of photons, just a big thick blob of photons, all at the same frequency. Individual rays of photons, just zillions of them. So that's what it shoots. And the X-ray is shooting essentially a much more confined number of sources, and the sources are in the polarization, the alignment is much tighter. So the radio wave has very weak polarization, very scattery, and the X-rays have very tight polarization. Strong ray, weak rays. Big mass of photons, much smaller mass but more confined. Distributed, more precisely, if that's the right word. A narrower volume, something like that. Alright, back to the comment. Alright, amplitude of the light. So, the amplitude of light, the amount of light, just has to do with how many rays and how long the rays are. How continuous. That's the volume. Alright, I may be willing to partially accept this theory because it combines particle and apparent wave behavior. So again, you're saying it does. I'm saying this idea, again, this ether idea just totally fails for me in the sense of the conceptually. Again, what this confined wave, this idea that it doesn't spread, it goes in straight lines when you want it to. And then what? There's some just magic rule where all of a sudden now it goes big and it spreads in this direction and it spreads in this direction. I just don't see how it helps in any way, except in the sense that you just arbitrarily change the function of the medium and all of a sudden say the medium somehow knows that now the photon is going to go in all directions. So your wave goes to the two-slit experiment, for example, and somehow your straight little tiny discrete thing knows that now the ether says spread in all directions, but you're not really a photon. You're some new thing that now has spread in all directions. It can't be received as a photon in any one of those particular directions until somehow one element of it collapses somewhere, and then somehow all the energy that went sideways or all these other ways, that energy is pulled back in and put into that one discrete spot. That might make sense to you, but it seems totally, you're not going to be able to fix that. That's broken, and you're not going to fix it. Alright, particle and apparent wave behavior, even though it's not really a wave. Well, again, why use the word then? I mean, this language is just impossible. If people are going to allow waves to be bullets when they want them to be, the word wave doesn't mean much. Alright, I will run into the problem that if the theory above were true, light rays would be visible in space. Well, obviously they would be if you're saying when they perturbate that they're spreading. So, yeah, that doesn't work because you need energy for that to happen, and there's no evidence that photons spread their energy. This brings to mind how come I can only see light in a vacuum of space that is coming towards me. Well, it's not just that it's coming towards you, it has to hit your electron eyeball thingy. It has to hit an atom, fundamentally, with an electron in it. It has to jiggle that electron and cause other electrons to cascade. So our eyes are basically working like the photomultiplier, in that you jiggle one electron and all the other electrons are under tension. So when you jiggle one, you break free a bunch of them, because that little tiny extra bit of energy, they're all ready to be broken. It's like you've really stressed the glass. Like say you could use sound. You could use sound to vibrate a glass, and then you could just do a little click with your finger, and all you need is that little extra bit of energy and the glass flies apart. So that's the circumstance. Our eye is made so it creates a bunch of surface atoms that are highly unstable in terms of their electron configuration, and they're ready to be ionized, so to speak. Alright, also If the said theory were true, to transmit the pulses, EMWs, I don't know what those are, electromagnetic waves again, would mean the electrical current frequency would probably be equal to the frequency or the same harmonic. Alright, so that gets into how photons are created, and I don't think there's any reason to think that you need to, the frequency is a function of the, let's see how to state this. There's different ways you can look at an atom, and different ways, you can understand atoms to be things where stuff is rotating around. Alright, and so rotation would give you a way of creating frequency. In the sense you could understand that you could throw something off here, and so every time something got to here, it would throw off a bit, so that would create a frequency. And the other point I've made is that I think what's happening is that electrons that are capable of producing photons are electrons that have force between them, and that force is going backward and forward between the electrons. And I would argue that if you took two electrons that were far apart, and as you brought them together, that's where you create the resonance, or that's where you create the primary frequency, is that they will all end up just as the orbiting argument, just as when I was talking about the garbage rotating around a solar system having different directions. And the fact is the garbage that has more mass will end up consuming this direction, and it will own the day eventually. Well, the same thing happens in these vibrations going back and forth, and so ultimately when these two electrons end up next to each other, the bits going back and forth end up being sequential. And so if you were to move one of these electrons out of place and allow some of this force to go out, these little ping pong balls, however you want to think about it, sorry about the drawing being off. If you moved this electron so the forces now can escape, you could sort of understand that it's now in sequence, and that this is the vibrating distance between the two electrons. So if they're further apart, you end up with red light. If the two electrons are closer together, you end up with blue light. And this sort of explains why blue light is rarer or harder to create than red light. It's because the blue light requires you to push these electrons a lot closer than they like to be, and you need energy to do that, and that there's a certain limit to how much energy you can put in before you start creating X-rays, and that would be really, really tight. And so you're talking about a tremendous amount of external energy to be able to force those electrons that close together. And so then you end up with heat, you'll end up with a lot of other stuff that, it's going to be something that's going to break atoms to pieces. So it's harder and harder to create the shorter and shorter frequencies, because to do it means the electrons have to be much closer to each other. Alright, I think that sort of explains that. So let's see where we are. The same harmonic, okay. So I would argue that the harmonic's built into the atom. So the electricity doesn't create. So what I was trying to say there was atoms create photons, and most specifically electrons, electrons in proximity to each other that have force between them are creating photons. And they're automatically going to build the frequency. So you can put any kind of energy in, alright, to create the force that tightens them. So any force can do that. Just adding another electron can do that into an atom, can create more force between the electrons. And so the frequency of the light is created by the internal circumstance of the electron, and doesn't have anything to do with the force you're putting in. So you don't put electrical pulses in, or photon forces. I mean, it is photons, ultimately electricity, but the point is you don't need to put you don't need to feed it with a frequency to get frequency out. Frequency is built into the fact that as electrons move further or closer to each other, the frequency is the speed of light between them. That's deciding the frequency. Okay, I think that's clear as I can make it. If this, that, I just said were true, then I could assume that any AC current is capable of electromagnetic radiation of waves. Well, what you just said sort of indicates the opposite, that somehow the frequency of the inciting energy is somehow relevant to the frequency of the exiting energy. And I'm saying I don't think those two have anything to do with each other. It really has to do with the condition of your atoms. Some atoms will produce ultraviolet light, some atoms will not. No matter what you do, you can't make them do it. You can't force them to do it, no matter what frequency you hit them with, because their physical structure doesn't allow electrons to get close enough. Alright. Electrical would probably be equal to the frequency of the same. If that is true, okay. Could assume that any AC current is capable of electromagnetic radiation of waves. So again, the wave would be what I would argue is the force between the electrons. So whether we go with your wavy theory, I'm arguing that the wave is something trapped inside the atom, trapped between the electrons, and it's creating the force that forces electrons apart, and that force is magnetism. Okay. So let's say the radiation waves, then an antenna. Okay. Current is capable of electromagnetic radiation of waves, and then an antenna is unshielded wire that has AC in it that is appropriate length for EM propagation. So now you get into the, I've sort of been over antennas and radio waves, so I can do a little bit of that, I suppose, because it does get into this polarization argument and what and how the energy of this simple thing, which is the photon. So we'll say the photon is the energy always. Okay, it's whether it's moving electrons or whether it's light or whether it's magnetism or whether it's gravity, it's always one of these little bits, okay, and that's a photon essentially. It's moving the speed of light and it's a little discrete bit. If it doesn't have a frequency, then we can't identify it easily. We don't see it, but we certainly see its effect in the sense we see gravity work. So we see stuff move as if it's being pushed by something, and that's exactly what photons do, is push stuff. Alright, so the question about antennas and radio waves, better see if this is anywhere close to being in the drawing, which it is not. Yeah. Okay, so because radio waves don't necessarily have to be a ray. You're not necessarily detecting a ray at a frequency, which that are lined up, that have a polarization. So I would argue that it's hard to illustrate it, but I've made this argument before that polarization, I think, what's causing polarization is the alignment. So when photons or rays are lined up perfectly with each other, we'll call that circular polarization. And then when there's any misalignment, like they're not perfectly aligned with each other, it's a little bit off, because they're being ejected by an atom that's moving, Brownian motion. They're being ejected by an atomic system that's in motion. And some of that motion will be realized in how they're ejected. So you could argue that radio waves are not very polarized. Their distance from each other can be very great, and you can still receive them because you can receive you can receive non-aligned photons, essentially, just because of the way they're emitted. So again, the radio signal is really just a bunch of photons at a frequency. It's not the rays, they're all rays, but they're not, the rays are not lined up very well. And so when the other antenna is receiving, all that's really happening to the atom is it's getting bombarded, and all it has to do is have two hits at the right frequency for the electron to move the specific amount it takes for it to create a cascade of pressure that's voltage. So the electrons move, they create a disproportional circumstance in this conductor, in the sense that more electrons end up here than electrons here, and that creates a voltage potential that we read, and we read the potential based on these hits of all of these tons. So it's not as ray dependent, and so it's not as polarization dependent, where other kinds of light you can block it based on polarization fairly easily, and you won't receive the signal anymore. So radar, you can use a really thick polarizing filter. I mean, very lines, steel bars that are an inch across, and you can detect the polarization, that is the amount of spread there is. So even with something like radar or microwaves, the spread is already getting pretty big in terms of the alignment being off. And radio waves, the alignment's off even more. Really big distances of misalignment. And that's why we can't do much. That's why radio waves don't have much resolution. Not very good to see with. So the real point is that the tighter the polarization, the better you can see with it, essentially. The more detail, the more resolution you're going to be capable of getting, because there's going to be less noise to signal. More noise, less noise to signal. Yeah, I said it right the first time. So I think that completes your statement. So let me just see if there's anything else I have to say about it. Okay, capable of electromagnetic radiation of waves, and then a antenna is unshielded wire that has AC. So he's just saying a plain wire antenna has AC in it. So again, this idea of AC, well, yeah, it's on and off. You can call that AC, but it's really just on off. The signal doesn't reverse. So the antenna is picking up on and then off, on, then off, on, then off, on, then off. So it's not technically AC in the current, it's not alternating. So this is another place where, again, the language is a little bit broken, because now we've used the word AC for any current that is on-off, but there's a big difference between reversed and on-off. Reversing the polarity, that's real alternating current. On-off is not alternating current. Photons present, no photon. Photon, no photon. AC isn't something a photon can create. It can't reverse the polarity. And so the devices we connect to the antenna create the alternating current. The antenna doesn't create it. The antenna doesn't reverse the polarity, ever. This doesn't happen. So yeah, that's a whole nother, I mean, I know I did videos on that too, but I'm just saying, so that's a whole, you can get into that whole subject of what the nature of a signal is. And I sort of had this argument with Hoffaday about the radar experiment and the two-slit radar experiment, and why it's just overlapping frequencies. It's essentially a jamming experiment and has nothing to do with anything called interference. Even though the word jamming and interference sound similar, I'm talking about the pattern. There's no interference pattern created by single waves interfering with themselves. It's just the fact that you have overlapped a radio frequency And by overlapping the frequencies, two frequencies like this, okay, if you overlap them, your detector can't see this or this anymore. It just sees this. So it sees 4 instead of 2. So it can't receive the signal because it's the wrong frequency. Alright, so I've been through that. Alright, so that's probably good enough, right? Yeah, it's enough of a video. So I do wish to make the next in the series of Start Here type videos. I just want to kind of do a video summarizing all of the extraneous parts of physics, the time dilation stuff, blah 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 blah, because I don't think they deserve whole videos to explain why there's no evidence for the cause and effect chain conventional physics is written, that time is bent. No, time is screwed up in terms of your measuring devices break when you give them velocity, and that's the simple truth. Nothing about time changes. The only thing that changes is the function of the device you're accelerating, and it goes through a change. But there's no reason to believe that if I start accelerating you towards the speed of light, like even half the speed of light, that your molecular change will be so dramatic that you won't be alive anymore. It will kill you. You know, it will have effects that have nothing to do with some scale where time just gradually slows down. There can be, it's like the idea of taking a hourglass and moving it out of gravity. Its function is broken. It can't function without the gravity. It's broken. And different clocks, because of different mechanics, will be affected by movement in different ways. Like if I move this, the speed of light, and maintain the gravity, but just moved it sideways very fast, the amount of friction created on one side would be so great that the flow would be completely degraded by the experience. Now, it wasn't time that changed. It was just the fact that now you've changed the amount of friction that the sand is enduring to get through the hole, and a lot less sand will get through it. So it breaks in very different ways depending on the clock. And the fact that atomic clocks break in somewhat consistent manner when you give them velocity is completely intuitive. It makes perfectly good sense that that would be like that way. You know, that atoms would degrade in a specific way as you accelerate them. But there's no reason to think that every timepiece breaks the same way. And the timepiece of our material mechanism, our arteries and our capillaries and our blood pressure and all of these things that keep us alive, the idea that you can just move them any speed and they just slow down in some, like your heartbeat just slows down, everything just slows down, we're not going to break that way. Our clock will break a lot different than any progressive, predictable way. It's going to be a lot messier. Alright, so that's enough. So, till the next time and such. Especially when you think about how we have a ton of clocks inside of us. You know, there's a bunch of timing mechanisms that are completely dependent on a bucket filling up before the bucket can empty. You know, these kind of things. And all of those different timing pieces will break in different ways. It's like inside of us there are hourglasses and there are pendulum clocks, and there are all kinds of different clocks inside of us, and they're all going to break in very different ways. So you're not going to time travel in that sense. You're not going to move fast without it doing substantial damage to your physiological functions. I think it covers it. Oakley doke. So till the next time and such. Pretty much.